All right, and we're live. Welcome, everyone. My name is Costa. This is the South BD Hub Data and the Digital Divide Webinar 1. This is about keeping data science broad. I will hand it over to Renata, who's the director at the South BD Hub, to guide us through the process. What we'll be doing today is we'll be listening to 5 panelists on their experiences keeping data science broad, and then we're going to take questions from you. If you're watching the YouTube video, the chat over on the right is a great place to put your questions in. Thanks very much. Renata?
Hi, welcome to the Keeping Data Science Broad. Thank you, Costa. I am the co-executive director of the South Big Data Hub, which accelerates partnerships between business, academia, and government. Also at the Georgia Institute of Technology in Atlanta. And what we're trying to do today is part of a series on keeping data science broad. This is the first of 2 webinars, a workshop, and a third webinar that'll happen afterwards to bring in community colleges, universities, 4-year institutions, minority serving institutions, and everyone who's starting a data science program, and to talk about the undergraduate experience and envisioning the future. So first up, I would like to introduce Paul Anderson, who's from the College of Charleston, and he will be talking about their Bachelor of Science in Data Science, and is Associate Professor of Computer Science Department and the Director of the Data Science Program. So Paul, it's great to have you with us.
Thank you.
And see what I can do.
All right, thank you for having me here. I appreciate the opportunity to come on, and I really look forward to hearing what everyone has to say. I have a few slides. They're pretty text heavy, but they kind of remind me what to say, and people maybe can go back and look later. Let me try to share my screen real quick. Okay, let me make that big for you guys. All right, so data science at the College of Charleston, when I was thinking about what complications to kind of talk about and what are some of the challenges, I did want to kind of first start with what type of university the College of Charleston is, so it gives you a little bit of context about how we solved our problems, even though I tried to keep the problems as independent as possible. So the College of Charleston is in South Carolina. We were what I would consider kind of a small to medium-sized state institution. We have about 10,000 undergraduates. We have a historical focus on the liberal arts education, so we still try to maintain that even at our large size. So it's kind of a unique approach that we try to take. I'm particularly from the computer science department. We are separate from the Department of Mathematics. I know sometimes some universities have those together still. We have about 500 majors in total. Data science comprises about 50 of those majors. The math department has fewer majors, but more faculty due to service. So that's the kind of comparison between the 2 departments. The stats department at the College of Charleston is within the math department, or I should say we don't have a stats department, it's just part of. And we've actually been running our program for quite a while now. It was originally called Discovery Informatics before we had the term data science, and so we have updated it in the last few years, but the curriculum is maintained pretty steady. So the first challenge I guess I wanted to bring up that seems to always come back to me whenever I'm trying to do anything, whether that's change curriculum or introduce something new, is data science is still a pretty unknown entity. And I'm guessing most people get that both on campus and also to people in your different disciplines. So it doesn't really have the name recognition that English or biology or mathematics or even computer science, which is often misunderstood by IT or for IT all the time. So that kind of gets some unique challenge or gives us some unique challenges that I think we all have to overcome. We have to be very good communicators when we're talking about our program and why it's unique and why it's important and why it needs to be a separate program sometimes. It's also kind of questioned just because of its brief history. Some of the first conversations that I had that caught me off guard were kind of just people questioning how something so new could could be relevant and so on. So I had to kind of step back and say, oh, okay, that's a question I wasn't expecting. But even those, I think, with experience with data science have to deal with the fact that we have different definitions, different interpretations, and this really crosses over both industry and academia. If you meet with a data science company, they have a very particular notion about what that means. If you meet with folks in the math department or stats or CS, and there isn't really like a great consensus. I'm sure a lot of us have been to various NSF panels. Seems like they're having a lot of those recently about trying to define this field. So what are some of the things that we've done here to kind of do that and some of our specific things? So I would start by saying that even if you have all your disciplines kind of agreed on some kind of proposal or change or something like that, the curriculum approval process, in my experience, can still be a little difficult. So this is saying that even if you get math and stat and CS and your domains that you want to involve, business or science, all to agree on like a great curriculum and you're ready to push it forward, you still have to go through that process. You still have to communicate and talk to people outside the field. So that can be kind of challenging. I have kind of coped with that and deal with that by trying to get a small team of people who I really like, who can really help push through the curriculum, and everyone can kind of pick up the baton every once in a while and keep the train moving. And so recently we've spent some time updating the domain component of our curriculum. I'm not going to talk about our specific curriculum. You can look that up on the website. But this in particular, we moved from a very specific cognate domain component to a more flexible one. And that took a lot of, communication to other people on campus, because it's pretty unique that we, at least at our university, consider data science as applicable to so many different fields. And we wanted to reflect that broadness in our curriculum. And everyone from the registrar's office to the dean to everyone, we had to sit down and kind of try to convince, like, this is real. Like, we're not just like taking a shortcut to prescribing like a really specific curriculum. So that was an interesting challenge to try to overcome. And then obviously a lot of people have to navigate, and we do as well. You have math, stat, CS, business in there, depending on how analytics heavy your program is, all of which are kind of have their own perspective to shape their different disciplines. Our approach for that was to focus on a core that we could pretty much agree on, and then provide some flexibility and opportunities for electives and a domain component. So the second challenge that I wanted to talk to was recruiting students. There's a lot of different ways to think about recruiting. And one of the things that's always constantly on my mind, because I'm teaching the courses and I'm the director of the program, is just recruiting students that are a good fit. So everyone's program is going to be pretty unique because the field is pretty broad and allows for that flexibility, which is great. And so when I'm recruiting students, I really want the students that are ready for our particular data science program, which is pretty intense when it comes to math and stats and computer science. So in addition to that, even if your colleagues kind of know what data science is exactly, how is a high school student going to know what data science is and whether or not that's a field for them? So that's another issue I'll talk about in a second. Whether or not your curriculum is prereq heavy, how do you solve some of those issues? Because this is a very deep field as well as a broad field of knowledge that students need to learn. Can they pick it up as a freshman, or do they have to pick it up as a freshman, or they can pick it up as a junior or senior and still finish your major in a reasonable amount of time? How easy is it to double major? So these are some of the things I think about pretty consistently when I'm thinking about how they affect recruiting. And so how I try to mitigate and deal with some of these issues so the way I deal with the fact that like our data science curriculum is pretty intense as far as math and stat and CS go, we have an introductory data science course. I'm sure pretty much everyone has one. And when I first joined the program about 6 years ago, one of the first things I did was revamp that course so it was like a little microcosm of the degree, because I felt that it was very misleading to have kind of a survey lightweight course at the beginning that really, it's not that I want to blow people out of the water in this first course and set it at such a level that they never can get through it, but I want them to get a taste of what the rest of the curriculum is going to be like. And that's really helped us retain and recruit the right students. We obviously lose some students to that because they come in and it's not what they expect, but we also gain a lot of students that come in and they're like, oh my gosh, this is actually, I thought I wanted to be a computer science major, but this is actually what I want to do. This sounds awesome. So it kind of goes both ways. I'm not exactly sure how to recruit at the high school level. I mean, we've done various visits, we've done advertising. I'm not so sure I've seen a lot of direct payoff with that. Instead, I've kind of shifted the focus and try to work on our website, things that reach a more broad audience. And then as far as whether or not a curriculum is prereq heavy and what that entails, it used to be very, very prereq heavy, and it still is to a certain degree because we're looking for depth of knowledge in stats and math and computer science. But we've done a lot to try to alleviate some of those pipeline issues that affect students that are kind of coming to this curriculum, maybe in their sophomore and junior year because they didn't know it existed as a freshman. So those are things I would recommend everyone think about when they're constructing their new great, exciting curriculum. And then that kind of translates into how easy it is to double major as students find you from different disciplines, right? Maybe they say, I really like biology, but I like data science as well, or I like economics and I like data science. So how flexible are you going to be and try to make your curriculum so that they can pull off a double major? So all those things kind of really go into how I like to think about recruiting. The third and final challenge I just wanted to mention really briefly is that a lot of you, I think, are probably going to have some version of a capstone course. So we've had multiple iterations because we've had our program for so long. And I just wanted to mention briefly kind of what I liked about each of them in case you're thinking about those things. For us, a capstone is a single semester senior synthesis course that brings together all the disciplines. The issues that I see with these things is that the department resources are often very stretched. What discipline leads the capstone? Is there a real world component? And so on. So dealing with this, our first iteration was an individual enrollment course where a student and a mentor were matched up. This was good that it distributed the resource workload, and it led to customized project, but we didn't really have great training for the mentors involved. It's a little too scattered to kind of give a consistent experience for the students. The second iteration tried to move a component of that inside a single classroom. So we have a single professor overseeing all these projects, and we still have the individual mentors. While this was good, it still ended up being a little bit problematic as far as getting what I would consider a full data science experience. What we've kind of settled on, and where I'll end my kind of talk, is the fact that our students now are working in teams. These teams can actually have CS, math, and data science people on it. The real difference is instead of having one student per one project and one mentor per one student, we now have these teams and we solicit the projects way ahead of time. So we vet them about whether or not they're appropriate, make sure that they're fully kind of explained and spec'd out so that the teams can execute them. This gives us a much more consistent and I think impactful data science experience at the capstone level. But obviously we lose some flexibility in the ability of tailoring it to some of our honor students and some of those type of things. And hopefully I haven't gone over too much of my time. So thank you, everyone.
Thank you, Paul. No, this is a great experience to say, and it's good to show that you've had experience over multiple years of doing it. So I want to prompt and just say that people can ask questions in the chat, and we'll ask them of all of the panelists at the end, or if we're going forward. And so also in the next speakers, we may be able to respond to some of the same things or see some of the same challenges too. So going forward, I'd like to introduce our next speaker, who is Mary Rudis, who is she's going to talk about a program from Great Bay Community College. Lovely to have you. She's currently at Bates College. And she was integral in putting together this program. It's really this certificate in practical data science and an associate's degree in analytics. So Mary, welcome.
Thank you for having me. I really enjoy being here. All right, so Costa is going to be running my slides, so if you hear me saying next, it's just a simple signal to him to change the slide. In the next 10 minutes or so, it's my hope that you will come away with a deeper understanding and a broader understanding of what today's community colleges are doing and the role that they play in developing programs for people who don't always know what they want out of life, but have the desire to better themselves. Next. So, good news is that educational attainment overall is increasing. The National Center for Education Statistics published information recently showing that the percentage of 25 to 29-year-olds with associate's degrees, bachelor's degrees, master's degrees, it's all on the rise. So that's the good news. Next. The challenge is, and this was something that was a big eye-opener to me when I was doing some research about 5 years ago on this subject. The challenge is that, at least in science and engineering, in STEM fields, those who go on to complete bachelor's and master's degrees are not as diverse as we would like. And as you can see, I mean, you can't even see the areas that are shaded in for some of these races because of how large of a number the white category is. And the stars represent races where more than half of them are actually starting at a community college level prior to moving on to more furthering their education. And if you can't read that, the stars are on the Black or African American, Hispanic, Native Hawaiian or Pacific Islander, and then those who identify as more than one race. Next. It's also not a very good story when we talk about non-traditional students. That is, students that are coming from families in which either the father or the mother or both parents do not have an education beyond high school or do not have any kind of a degree higher than high school. To the left of the red line here, we have, you can see among those students, among those achievers, people who get their bachelor's and master's degrees, more than half of them start out at a community college prior to getting their bachelor's degree and going on to furthering their study. And those are the ones whose parents do not have bachelor's degrees, do not have master's degrees. So this is showing us that there's a self-perpetuating kind of phenomenon happening right now in our society, where it's the kids whose parents have degrees who are going on to get degrees themselves. And so we're not going to see the diversity problem solved unless we can solve this problem of helping students who come from non-traditional homes get themselves into a college setting. And not just college, but you know, STEM related fields. And this is at the heart of what I was trying to do when I was creating the programs. All right, so wait, it just occurred to me that you're probably not on the same slide that I am, are you? There was a slide. There was the slide that showed the infographic from the state of Massachusetts. Let's see. Costa, can you go next to the slide where the road to bachelor's, master degrees in S&E by father's education, please. Are you there? Just nod if you're there. No? Okay, we're going to back up because this will only take a minute. Back up to the slide where the Massachusetts data was on degree completion. There we go. That's the problem with, sorry. Back up to that. The plan here was that I wanted to engage you in an exercise to show you exactly what it is that we deal with at the community college level. And the kinds of students that come to us are not necessarily, have not necessarily been trained throughout their life to be curious and to want to know more about the world. So for those of you here, here's the exercise. You look at this infographic, and I want you to just imagine for the moment, what is the next thought that comes to your mind when you see this? So go to the next slide. And those of us who are on this involved in this webinar are going to all be thinking that maybe one or two of these questions and maybe other questions similar to it, you're going to have a little bit of curiosity about where the data came from. How was the data collected? Did anybody bother to look at other data that might have been related to this? You know, we just have this natural curiosity about what is going on in that infographic. And I mean, the basic idea there was that the state of Massachusetts was trying to claim that they were the first state to reach 50% of the labor force, achieving some kind of bachelor's level or higher degree. Well, so there's all kinds of questions that come as a result of that. But in reality, a student coming to a community college who does not come from a home where the parents were involved in sciences or STEM or college level academic pursuits. And so a lot of students that come to community colleges today still need a little bit of help in developing that natural curiosity that the rest of us take for granted. So now go to the next slide. All right, so here, this shows you where the educational attainment overall was increasing from 2010 to 2016. And that, you know, that's good to see, but that's not the whole picture. Next. So this is what I was trying to get at before about the fact that the white people who identify as white are largely the ones involved in higher education and STEM. Next. Not only that, but we also have, as I was saying, students or kids, not just kids, but these are older adults as well. People who come from backgrounds where one parent, or at least the father in this case, did not have any education beyond high school, are not getting those higher degrees. And those that do, more than half of them are starting out community college. Next. Okay, and here again is where we see that a huge, huge portion of people going on to get their PhD in STEM it's very off balance. And next. So I was looking at all of this data 5 years ago. And as a member of a college in New Hampshire, I just felt compelled to do something. And you know, it didn't even occur to me just how bad it really was. So I asked the question, how can I help? Next. So in 2013, I applied for an Innovation Fund grant through the Community College System of New Hampshire to create an undergraduate certificate in data science. These were the objectives and goals. We wanted to support the needs of greater New England companies by providing a modern curriculum, a foundational set of coursework that students can apply immediately and slipstream into either a 4-year or higher data science program. And also, we knew we needed to enhance existing computer science and computing resources with modern data analytics and visualization tools. So we asked for $10,000, we got $5,000. Next. But that didn't stop us. So the first step was to ask the question, who's hiring? One of the big things in community college programming is that I have to be able to show my VPAA and my chancellor that there are companies out there that are prepared to hire our graduates. And I reached out to executives in industries like healthcare, insurance, financial services, you name it, the big ones in the greater Boston region. I reached out to the data science community at large, and I reached out to other institutions of higher education. And they're not promising at the time. In 2013, I was told that nobody hires a data scientist unless they have a master's degree. And if there were internships available, they're going to students like MIT grads and people coming from the big 4-year research institutions. Where the glimmer of hope came was when I spoke to someone at UNH Manchester, and I found out that they were creating a Bachelor's of Science in Data Analytics. And they actually were very positive and wanted to work with me to create an articulation agreement that would allow a student to transfer from a community college to the 4-year program. Next. So this is where we started. We decided, in order to address the issue of how do you recruit, like how do you figure out what students are going to make good data scientists? Because the students don't really know, they don't know what data science is. So we created the certificate as a means for existing programs to sort of embed them as like a stackable credential in their existing programs, but also to give students an idea, hey, is this for me or is it not for me? And by the way, we felt pretty strongly about including an arts class. The arts class here is visual language, because in my mind, you can't be a data scientist unless you really can think creatively with color and with presentation and with communication. You must be able to communicate. Next, almost done here. The associate degree was designed as the transfer program, like I said, but it also includes courses from the certificate. It is a very rigorous program, just like Paul had said before. His program is equally rigorous to ours. Lots of computer science, lots of math, calculus. Next. And that's it. So thank you for your patience with me there when I was getting a little bit mixed up with the slides. Thank you very much.
Thank you, Mary, and for all of the background too, and how it's been incorporated and evolved over time. So I mean, this is a really interesting program, and I'm interested in, our next speaker is, and how you might respond to the links. That's something I'd like to hear once we get all of the panelists about the links between 2-year colleges, 4-year colleges, and where that overlap is really necessary for workforce, and how that connects to industry, our industry in your areas. So we're gonna go to our next speaker, and at the end, I'm also gonna get questions again from the people on the chat. There's been several that have been generated so far. So we're going to bring those in as well for the whole panel. So Carl Schmidt is our next speaker, who is the Director of Data Science at Valparaiso University, an assistant professor in mathematics and stats. And he has even a blog about how his program and the creation of the Data Science Bachelor of Science and an undergraduate business degree with a major in business analytics. So Carl, welcome.
Thanks. So first I want to thank the organizer for having us all. I'm excited to hear everyone else's stuff, gets new things. And I also have to give a shout and a thanks to Paul, because it was one of Paul's workshops at SIGSI a few years ago that actually got me on the kick that even got us a program at Valpo and on a blog. So that's why I'm here at all, because of what Paul had previously presented about his program. So, and I'm going to actually echo a lot of the things that, or some of the things at least, that Paul was talking about in the challenges and sort of the things that I want to talk about. So I thought something that might be really useful for everyone to sort of hear as they're thinking about how to have, like, if they're going to make a program, what goes on with that, was critically thinking carefully about, what makes your program different, both at your university level or college level, but then also sort of in the marketplace in general. So to give you a little bit of context on that, I want to first let you sort of know where Valpo is. So we're, I believe, officially classified as a medium-sized university. We've got about 3,000 undergraduates and about 1,000 to 1,500 graduate students. But we have an unusual situation at what is essentially a liberal arts college, or feels like a liberal arts college, is that we actually have about 500 undergraduate engineers without a master's degree. And we've got, I think we're ranked in the top 15 or top 10 engineering programs in the country. So we've got a really strong engineering program. And we've got a master's degree that has in information technology. So we've got somewhere between 100 to 200 master's students in information technology running around. I share this because it's important to understand sort of where our abilities to offer even a data science degree comes from. And because of that strong undergraduate engineering population and a strong meteorology program and some other things, we actually have a really large mathematics and statistics department. And soon after I got to Valpo, they were combined and split into 2 different departments. You can see the numbers up there. Our math for our size of a university is huge. And our computer science department, on the other hand, is fairly small. Most of that IT degree is being taught by our adjuncts and our lecturers. And so, but with that large size of a large full-time faculty in math, we're actually able to offer a lot more math and statistics than perhaps another university of our size might look like.
Carl, a quick interruption. Just some of our viewers are saying you're coming a little bit staticky.
Okay, I have no idea how to fix that. Are you guys hearing me relatively clearly?
It's coming in a little staticky, so it could be the microphone. Did you switch mics, or?
I did not switch mics to my knowledge. I should be. The only thing I did was install that the webcam software that lets me Zoom.
Okay, all right. We should be okay then. Sorry for the interruption. Just wanted to see if we can solve that quickly. If not, sorry to interrupt.
I can move a little bit closer, and I'll turn my self volume down, so maybe I'm getting a little less echo. So I want to talk a little bit about where Valpo was before we proposed our stuff. So we actually had a lot of analytics and statistics sorts of things around. And so our business college had started a business analytics degree a couple years ago. We've had a master's degree in analytics and modeling for almost 6 or 8 years now. Similarly, we've had a graduate certificate in data science sorts of things for at least 5 years. And so soon after I heard Paul's presentation at SIGSI in 2013, I came back and started work on proposing a data science degree. And we actually proposed a statistics degree in the same year because we sort of were offering that many courses. Part of the challenge with this also, though, is that all of these programs are not housed in the same place. So it's not like there's one person, there's not one level of authority overseeing who gets to put these into place and what goes into them. So the statistics and our minor in statistics and where our data science degree ended up being housed are all in our math and statistics department, although we have close ties with the computer science department still. The business analytics is obviously in the College of Business. And then the graduate degrees are officially housed under the graduate schools. So even though we sort of control them in the math stat, they're through a whole bunch of different sets of paperwork, which is always a fun thing. So part of what we did as we were working on proposing this was that we were looking and thinking about how at Valpo as a whole, like where would students be going if they wanted to do different things? And so one of the things that sort of drove our thoughts and discussion are these ideas of needing different types of data users. I really like these charts from O'Reilly from a book they put out, where they're sort of talking about different people that use data. So there's data business people, where they're looking to have a strong business component, and then enough skills and elsewhere to be able to understand stuff. There's people that are data creatives, which have a lot less business and a lot more sort of statistics and programming pieces. Data developer, which is kind of similar to the data creative. And then a data researcher, which has a lot more like math or statistics, and so they're really developing algorithmic things. And so part of what this let us do, sort of articulate where people that might be wanting to do these different things should show up. So for example, it's pretty clear our business data people probably should be going to our business analytics degree, where they're getting a much stronger business education. We specialize the data science degree to sort of tackle the data creative and the data developer. And for the most part, our statistics degree covers this sort of data researcher, where they're doing a lot of statistics and they're getting a little bit of other things. Part of what we also had to do is talking about this differentiation, and we can articulate this more clearly by sort of answering a couple of questions about this. So why do we even want to have a data science degree when we already had a business analytics degree? And it's already hard enough to articulate what business analytics is, let alone what data science is. So this is that same kind of question that Paul was raising about unknown entity. No one knows what it is. So for us, our data science degree has a much deeper and stronger rigor required in the statistics and computer science curriculum. And that's partly because it's hosted in the math and statistics world. It's also because it's hosted outside the College of Business. The general education requirements for students taking it is much broader. So instead of taking a whole almost 40 or 50 credits of business general education, they get to just take broad general education, which lets them get skills for different for applications in other domains. This also makes it a lot easier for students who are interested in double majoring, because it means that a lot of those general education credits can actually be counted towards a second major. We also had to talk, especially inside our department, about why we were introducing a data science degree at the same time when we were actually introducing a statistics major and already had a minor in place. So our statistics degree ended up covering almost all of the stat classes that Valpo offers. And that was about it, because that's about all we could fit into the major in terms of credits, which meant that there really wasn't any significant non-statistical programming. So they take a programming course in SAS, and we just recently are going to add a 1-credit programming course in R. But that means that if they just do what is in the major, they're not coming out with very strong coding skills necessarily. Similarly, there's zero need or requirement for them to take anything about databases or data or that sort of other end of working with pulling data into what they're doing, which is not to say students couldn't choose to get it if they took extra classes, but they're not required to. So we felt like this is really a distinction between a data science degree and a statistics degree, but also that it's not really creating someone that's a data science per se without some of those other deeper skills. Similarly, they don't get a lot of exposure to machine learning or AI topics, although again, there's minimal exposure in some places. Something else we didn't do, and this is, so I'll be interested to hear how people did their data science minor, and people keep asking about it. We don't have one, because if you look at our actual curriculum requirements, we have such a broad range of core skills required in both math and statistics and computer science that once we got through the 5 classes, that they would be required, that they would take in a minor, they hadn't actually gotten to anything interesting in data science besides like the intro to data science class. So they would have taken a statistics class, an intro programming class, a math class, and some other things, and they wouldn't have really gotten what they thought they were getting with it. And if we wanted to make it a little bit closer to what they thought they would be getting, we basically have built up our current applied statistics minor. Now, I put a caveat there in that there's been some discussion over the last year or two here at Valpo that we might want to introduce something that would be kind of like an advanced minor that would allow students, especially people that have strong backgrounds. You know, a lot of our engineers take all of the math and programming classes that we would have as prereqs anyway, where they could add a minor on that was just really the upper level classes in data science, and they'd be able to put it on their transcript, and we wouldn't have to require a bunch of prereqs. The other side of differentiation is also differentiating yourself in the marketplace. And so for this, I hope all of our colleges will end up doing things differently, because otherwise we're already competing for some of the same students, but we want to also be helping the students find the best place for them and helping us all get students. And so for us, we decided to sort of focus on some of the things that Valpo already does really well and they're going to get out, and try to make sure that that's sort of something that makes sense for our program to be good at. And so 3 of the strengths that Valpo really already does is, even though we're a full-fledged master's university, we still have a really strong liberal arts tradition, which means that all of the students that graduate from our general College of Arts and Sciences have really strong communication skills, both in presentation and writing. We also are a religiously affiliated university, and so as a whole, our student body tends to be very service-oriented and have a lot of service interests. We spend thousands and thousands of service hours every year doing projects and things like that, and so we wanted to sort of capitalize on that. And then also, because we're not a really large university, there's still a lot of strong different departments that have close ties. So it's actually really easy for students to be engaged in more than one department and not feel like they're just in a giant departmental silo. Obviously, they can be siloed if they want to. So what have we done with this? So Paul said he went and took his intro class and made it super rigorous, and you know, they get a real strong taste of intro to data science throughout the course. In some sense, I took it the other direction, where I didn't want it to be a survey course, but I also wanted it to be accessible to anyone without necessarily having any programming experience or more than just sufficient math skills to understand the statistics we're doing. And part of the way that we also did that was we get the advantage of having people at all different levels choosing to take the intro class, so I can match underskilled students with more skilled students in terms of achieving success. And what we did was we focused on having them be a project-centric course. And I modeled it after, in the miniature, the University of Chicago's Data Science for Social Good Summer Fellowship, thinking that I'd really like to see our program as a whole pull in projects that are nonprofit, social good projects, things like this. And so last year when we ran it, we worked with the U.S. Geological Survey, we worked with Meals on Wheels in Northwest Indiana, we worked with a social services company in Texas, and we did some faculty projects on campus that students were able to do interdisciplinary work with other faculty that needed help with their data. And this also sort of centers around this idea of having really application-heavy intro classes, which is a best practice from the computer science side. And then tied with that inside of our program, we've got a junior-senior year sort of capstone sequence where we're expecting students to do another major project over with a proposal and an actual capstone project. And that's probably going to evolve as we move forward. And just to sort of give a last sort of quick look at what our program looks like, just so you have a sense of it, I've put up the courses that we require. And so here you can sort of see we've got a very equal smattering across all of the different disciplines, where they're taking 12 computer science credits, they're taking 9 statistics credits, 10 math credits, and then some data-specific courses. And so this goes back to how we differentiate ourselves from any of the like math or computer science or statistics or business analytics, where in some sense students are getting minors in 3 different disciplines with a little bit of a specialization in data. but it's all collected together. And you can also see here now why we felt like a minor wouldn't really work, because till you require the first classes in each of these areas, you've already hit 4 classes, and then they get 1 extra level of class. And so that sort of seems not as helpful to students from other disciplines if that's what they like to do. And that is all I've got to talk about. So I'll be excited to hear questions from people after we're done.
Thank you, Carl. Yes, it's a very interesting program, and it actually is a lead-in to, we have a webinar too that we'll talk about later, but it's alternative mechanisms for data science, and the data science for social good is something that we actually just sponsored the one in Atlanta this year, so for the data science for social good. So it's interesting that you modeled your intro class after that. And one of the questions we got in the chat, you actually talked about when you were talking about your differentiation between, you know, business analytics, data science, and the different areas. So we'll come back to that. And as we go forward, so our next speaker is from Auburn University, and she is Dr. Pei Yu, who's an assistant professor in the area of business analytics. And she's going to be talking about their business analytics degree. And our next speaker will also be talking about a minor, so that'll come back around to like the difference between minors. So, hey, welcome.
Hello. Hi, thank you for having me. This is Pei at University of Kentucky. I am sharing my screen. Hopefully everybody can see that.
Yes.
That's good. I have learned a lot from the previous presentations, and it's so excited. I would like to give you a general idea about Auburn, the program, Business Analytics undergraduate program at Auburn University, and then I'm going to talk about some of the challenges we are facing now. And we founded in 2013 with the very precious support from the major administration, because before that, our dean envisioned setting up a business analytics program in business school, and he actually wrote several articles about business analytics. And with such support from their major administrations, and actually it helps us a lot in expanding our program. Just want to give you a general idea on what programs we are doing now related to business analytics. We have undergraduate business analytics program, and we also have a on-campus and off-campus MBA program with concentration on business analytics. And we also have graduate certificate program. Also, there is we are working on offering a PhD program related to business analytics. And when we founded in 2013, we only have 3 sophomores. Now we have, if you're adding up those numbers together, we have 84 majors and 16 minors, and that's adding up to 100. That is super cool. And this is a general idea of what we have in setting up for the majors. There are 7 major courses, and you see that the courses are set up around what we around how we're solving analytics programs. So everything starts with making sense of problems, understanding opportunities, and formalize the problems. So we have a course called Communicating Quantitative Results, and this course has been offered around the very beginning of business analytics, and also we have this course developed around the very last step of business analytics, which is delivering the results with presentation. And within the beginning and the last step of analytics, we also have data preparation step. And for this step, we have 2 courses offered, and one is Business Big Data 1 and Big Data 2. The 2 courses help students learn to clean and merge, attract useful information for further analysis. And then we have 2 steps. One after that, one is modeling process, the other one is analysis. For the modeling processes, we help students to form an empirical model around the programs that we're asking here. So we have actually 2 courses offered around it, Business Analytics 1 and Predictive Modeling 1. And also for the analysis part, we have using specific methods or regression, machine learning methods to deal with the models we set up. And we have Business Analytics 2 and Predictive Modeling 2 offered. So this is a general idea of our curriculum. Next page here. This is just want to give you a general idea how those courses being covered. So in the very beginning, the very first year, they did not really get to learn any course related to business analytics. But later in the second year, they're gonna be offered with the basic business courses, like have a general understanding of accounting, supply chain, there's different courses to get prepared to understanding business questions. And then they have Business Analytics 1 and Business Analytics 2 offered during the second year. And third year, they're gonna play with real data. They have Big Data 1, Big Data 2, Predictive Modeling. And also in the fourth year, the senior year, they have more related courses and they get to choose several business analytics electives. So that's a general idea of how we set up the curriculum. And this is why it's attractive. The program is attractive. We have several tools offered, and this actually gonna be one of the challenges I'm gonna mention in the later slides. And one thing we are very proud is we have 100% placement rate after their graduation. Here at Auburn, we try to foster a very good relationship with different organizations, and you see that we hold cooperative information sessions each semester. This is a list of what we're offering this semester. Some of the challenges I want to talk about. The first one is finding the qualified people with appropriate skills to teach various courses. We started in 2013. When we first started, we only have 2 full faculty members and 1 instructor. And in 2014, we hired 2 new faculty. 15, we hired another 2, and 16, we have hired another 2. So you see that how we actually expanded from a small group to a big group with a big number of faculty members devoted to the business analytics area. The hiring process is a challenge for us. Another thing is I think this is something that Paul had mentioned before, how to recruit students. Most of students are daunted away by the quantitative nature of the materials. When they first learn that they're gonna be computer science technologies and such as the programming language, Python and R gonna offer in the class, and also some statistical tools gonna be offered in class. They are a little bit worried about whether they're gonna have a good understanding of the materials. And this one is much relieved by shifting our emphasis on how we make sense of the business analytics. We are very heavily project oriented. Let me give you an example of what we are doing in my class. I'm teaching Predictive Modeling 2 this year, and we are working on projects that having students looking at the renting market. And because Auburn is a small college town, we only have 60,000 population, and I think among them, more than 20,000 are students. So the renting market is very demanding here. So we having students looking at the renting market and also having them looking at the housing values. Look at what are the attributes going to influence those, and also having students predict the traffic during the game days. You know, football is a big deal here at Auburn. We also have people to look at the text information on Facebook pages of Auburn football, and we're having them to understanding the sentiment of those text messages, those messages on Twitter and Facebook. So they actually have fun. They are having fun in doing business analytics, and this partly relieve their anxiety in learning the materials. The third challenging we are facing here is the overlap in course content. But this one refers to, since we offer many different major courses, unaffordably, faculty members gonna cover some of the content repeatedly. For example, how we transform the data, whether we do a log transformation before running any model. So as I said, we have big data working around dealing with cleaning and setting up the data. And we have predictive modeling covering the modeling process, and which is built upon the cleaning process. So there is some overlap in covering the course content. I think those schools who are planning on offering a business analytics program should have a good discussion on which part of the material should be covered in which class to avoid certain overlap. And the last one is the choice of analytics tools that are going to be covered in class. You know, we have several academia program representatives from different companies, such as SAS Enterprise Miner. That is one of the tools we're using in class. And we also have representatives coming and training faculty members on using SAS Cloud Analytics. And we also have training sessions on IBM Watson, and we also have several other ones. So there is a debate among faculty members on what type of tools should we cover, should we teach in class. Now we're trying to give the student prepared with a full set of different tools. We have Python and R, SAS Enterprise Miner, IBM Watson, and we are considering incorporating SAS into our curriculum too, so that they are well prepared. But on the other hand, we try to emphasize that the tool actually is not a very big deal over there. The concept of the analytics behind that is the thing that really important. And again, we also emphasize that to make sense of the business program, to learn to ask questions, what kind of question we can ask, and how we deliver the results as a reporter to managers, and what kind of business implication you can draw. Those are the things that we really want to emphasize along the way they are tackling the real world applications. Okay. I think that's all I want to share with you guys. Let me know if you have any questions. Thank you again.
Thank you, Pei. Yeah, it's a very interesting program, and the fact that you've thought through, all of these different layers that you're talking about as well. And we'll get to a question that we have in the chat after the next and our last speaker about prerequisites. And I was very interested in your comment about faculty and how you get incorporate faculty for training. So our last, but definitely not least, presenter. Oh, hold on, let me make sure that I'm sharing my screen. Is Jean Ray, who's the Associate Professor of Statistics and the Director for the Center of Statistics and Analytics Research at Kennesaw State University, where he's going to be talking about their minor in applied statistics and his work with the challenge in data science education of looking at experimental learning through partnerships with industry. So Jean, welcome.
Hi, how's everybody? So a little bit about our program. Well, I guess first about the university. So this is a quick outline of what we're going to talk. Let me make sure that I'm sharing my screen. That's probably the first thing. So today we're going to do a little bit of background. Many people are not very familiar with Kennesaw State and where we are, so we're going to talk about that, how our department grew up, and then the program. And then from that, there's really two types of experiential learning that we're kind of experimenting with. And so I thought I would focus specifically on kind of that model And then the benefits and issues, because it's kind of a really specific thing. We're a really large university. We have about 35,000 students. We're located in a northern suburb of Atlanta. So because of that, we have access to a huge kind of tech hub here in Atlanta. We offer about 150 degree programs. We also have a master's in applied statistics. And then 2 years ago, we started a PhD in analytics and data science. And I teach in both of these programs, as well as our minor program. That's more so the emphasis for this talk. Our department started off in the mathematics department. So in the early 2000s, there was this drive to start a statistics program. So we started really small with a minor in applied statistics. So we first formed an advisory board with some of the executives that we thought would hire our graduate students. And out of that, kind of devised a curriculum. Also, because of our history, we have a really diverse set of quantitative backgrounds. So we've got people from statistics, biostatistics, epidemiology, industrial engineering, decision science, and we just recently hired a faculty member with educational psychology, primarily because of the structural equation modeling. So we've got a very diverse set of backgrounds. It could be challenging to make curriculum decisions. So the advisory board definitely informed some of those early decisions. And this was started before kind of the buzzwords of data science came out in like mid to late 2000s. So that's also why it still has that more traditional applied statistics name. So it's really with the minor, we're focusing on applying statistics within some sort of domain area. So we end up with people from psychology, business, math, biology, coming to us to kind of augment their skills with some sort of quantitative techniques. All of our courses have a heavy applied emphasis. Even stat methods 1 and 2, we primarily teach SAS in. The computer applications of statistics, we introduce students to Python, SAS, R, a little bit of Excel, basically the tools you'd expect to find kind of in a business environment. And then all of our courses are really geared towards how do you apply statistics, not so much focused on the mathematics, given our diverse background of students in the minor program. Now, something that we identified early on was you have to have some sort of experiential learning environment for this to work. So what we were able to do is create 2 sort of types of classroom environments. One is regularly offered. So we've got applied binary classification and design and analysis of human studies. Both of these courses are direct partnerships with industry, where industry gave us their data sets and then let us use it in this classroom setting. So applied binary classification is really credit scoring. So it's teaching the students how to clean a massive data set, bin variables, analyze variables, and actually develop their own credit scoring model. Oftentimes this work gets presented at our own SAS conference, and then some of those go on to present at Global Forum or some of the other conferences, and recently have won some of the first place posters just based off of that class. The design analysis of human studies is designed by our epidemiologist, and so she's partnered with a company that owns many of the neonatology practices around the nation. And so she's able to collect data and develop growth curves. So hers is more like an intensive research environment for students. Typically, there's a graduate student that's over a research team, and then the research team is comprised of undergrads. And so they work together to figure out how to solve problems, do the analysis, and then actually get publications that the students are listed on. So those are kind of our more traditional course offerings. And then out of that, corporations started coming to us and asking, could you help us solve problems? We initially did this through more traditional consulting engagements, but as time went on, it sort of evolved into a sponsored class research project. A big relationship we have is with the Southern Company. So they're a really big power company that owns many of the local power companies amongst the states. They have a huge amount of data, and they're trying to figure out how do you transition into more of a data science space. And so they're using our class to solve problems that are of priority to them, but they either don't staff or can't resource. And then they're also recruiting interns out of that class. So that's just one example of this idea that we've sort of brought up. So obviously the benefits. The students get some real world exposure. Part of the class, especially those corporate sponsors, projects is that the students have to go back and present for the executives. And then oftentimes there's prize money that's awarded. And so the executives get to decide who's the winning team versus the non-winning team. That idea of a competition built within a class also sort of invigorates the students. In some regard, it limits kind of the traditional collegiate environment that you would hope students would have. But in other ways, it really pushes the analytics. I ran a click-through, like web click-through class for the Home Depot. And the amount of analytics that the students were able to produce over a summer semester was amazing, primarily because of this competitive environment. So it was really a neat concept. Oftentimes, the top teams that are exposed to the executives, they're offered internships and jobs. The more we do this, the more our reputation grows, and we're able to then develop deeper relationships with industry. We actually have a waiting list now of company partners wanting to do this sort of class with our students. So now the issues. If you're trying to do this, it takes a really concerted effort to develop those relationships with industry. There are all sorts of risks that the faculty member and the department sort of have to mitigate. There has to be some sort of vetting of the project to make sure that the corporate expectations of the project align with the skill sets of the students. Early on, we gave a fairly complex project to a mixed bag of graduate and undergraduate students, and the undergraduate students were pretty overwhelmed. So it also requires a lot of kind of client management and team management on the faculty member to make sure that you're meeting expectations of the partner while also kind of controlling the teams and making sure that the teams are able to function. Because if a team gets overwhelmed too soon, it's really difficult to help them move forward. And with that is all sorts of time required of the faculty member, meeting with the team members and making sure that the presentations are high quality, the analytics are appropriate assumptions have been made with data cleaning, that the whole concept of data science is really sort of taught within this framework. Luckily, several of our faculty members have came from industry. Like I used to run research teams for Thomson Reuters. So I'm very used to this and used to that time intensity, but I could see a new faculty member without that experience being completely overwhelmed. The other important factor is identifying the appropriate skills amongst your faculty who can manage the clients and manage with the students. That's also very challenging. So I really went through that. It all based off of this concept that to do data science or to learn how to do data science, you really have to do data science. So that's kind of where that came from. All right. Thank you. I will stop sharing my screen. Maybe.
There we go. Thanks very much, Gene. Renata may be having a little bit of trouble. So that's why she didn't jump right in. I'll hang out and wait for her, but in the meantime, we can try to go to questions. Renata comes back, she can moderate that. Thank you very much. Excellent presentations. Thank you from all our speakers. And what I'm gonna ask for here while we wait for Renata is if my assistant here can plug in a few questions just right on the Twitter to get us started. And we'll go from there. And for the speakers, if you do answer a question, go ahead and unmute yourself, answer the question, and then just click mute again so we don't have too much background noise. Okay, we have a question from Shannon McKean about prerequisites. What can high schools do to make sure students are ready for an undergraduate degree in data? So for any speaker who'd like to take a question.
So from my perspective, students that are looking to get into our program, I'm really just looking for them to have possibly a basic introduction to statistics course and some kind of programming experience. If they come in with that, they're ready to hit the ground running with our program the way that we've got it designed. Obviously, the more of either of those they come in with, the stronger their start's going to be. But for us, we built the program intending for students to be able to come in without sort of needing any pre-knowledge and still be able to succeed.
I guess from my perspective, one of the things that is most important is the ability to like think critically about a problem and figure out like how to approach it. I feel pretty strongly that like I can overcome any technical shortcomings. So if you don't know how to program, I can teach you how to program. If you don't know how to, stats, I can teach you stats. But this idea that like you're presented a difficult problem, you have to somehow decompose it into manageable parts that you can solve and somehow evaluate. I feel like that's something the high schools could really help us tackle. Just getting that going really even before high school and all the way through.
I'll add another 2 cents. If anything, I want someone in the high school is making sure that students knew what data science or data was, as opposed to math versus the physics versus computer science. Because I think at the end of the day, as Paul said, we can teach them whatever they need for this, as long as they're coming with a sort of a reasonable math background and a reasonable questioning background. But if they don't even know that the discipline exists and that it sits at these interesting intersections, that's harder to. Once they get to college, it's hard to get them into our intro classes to even interest them if they don't know to work for it.
Okay, another question here. What is the curriculum mix between data tools and data presentation skills?
So in our minor program, that's a big struggle that we have is because you spend so much time teaching how to do the analysis and how to bring in data and clean data that the presentation almost becomes an afterthought. So that's where kind of those experiential learning classroom experiences come in, because it's really where they develop their skills. We force them to rehearse, and then kind of that leads to other conference presentations and those sorts of things. That's really how we approached it. It was kind of extracurricular.
Great, thanks. Anyone else? Okay. Can community colleges have just one intro to DSCI course instead of a program? And could it transfer as a quantitative elective?
I suppose it depends on what kind of an outcome you're looking for. Usually for community colleges, you're really dealing with students who don't have much of a background at all. So, and that's part of. I mean, really, if a student doesn't have any background in stats and doesn't have any background in programming, it's really almost impossible to accomplish an introduction to here's what data is, here's what a data distribution is, and here's how to understand what data is trying to tell you. Oh, and by the way, you have to program at the same time. And we found that when we tried that at Great Bay, we tried sort of incorporating all of those things in that first intro to data science course, and students were just overwhelmed. So it depends on the background of the student, really. But if you're dealing with students that are just coming in cold off the street, it's not an easy thing to do in just one class.
Thanks, Mary. We've got Renata back.
Hello.
Yeah.
So,
would you like to take it from here? Sure.
My internet had decided to cut out right when the discussion happened, the good part. So I wanted to, if people can hear me, to ask the question about diversity. Do you have a way of measuring your diversity of your program, and what prerequisites may be required that you think would be required of high school students, that would be required of new entrants into data science, and if those are tied to your student body, or if you think there's just general prerequisites that anyone would need for data science?
I'll speak to that a little. I think that I think that we need to sort of move away from this idea of prerequisites in undergraduate education. And maybe I'm when I say that, but as you saw, the data is not good when it comes to diversity in undergraduate degree allocation. We have a huge imbalance of bachelor's and master's degree recipients. That it's not a representative of our population. And so I think we need to all come together and have a conversation, have a discussion about how we can rethink where we put students into when they come to our colleges and universities, and not just put them into whatever major they say they want to do, but maybe give them a little bit of flexibility in that first year of study and say, you know what, you're not going to declare a major right away. We're going to have you just try some things and then declare a major after their first year of study. And maybe that's one way of getting more diversity in data sciences and sciences in general. But you're right. I think we need to loosen up on the prerequisites, and I think a lot of the people on this webinar have already stated that they're accepting students from whatever background they have, and I think it's great that we're all attempting to train students from wherever they are, and just start working with them from the beginning and build their skills as they go.
So I can chime in a little bit about our program and about how I've been kind of monitoring some of the diversity. Some of the encouraging things that I've seen is a big thing in computer science is a lack of female participation, and I don't really see the same in my data science program. So at the College of Charleston, we actually have about 60% female across the entire college. But in computer science, I think we're doing better than most because of that percentage, but we're still around like 20%, I think. But in data science, I'm at right about 50%. Exciting to me. It's really kind of interesting in these introductory classes. Ours does not have any prereqs. We do have a big experiential learning component to it. And my main goal for that is just for students to kind of see what life as a data scientist is like. I told them that's kind of the only learning outcome from the first course, so that we can maintain its approachability. And I got to say, like, some of my most exciting and fun students really came and they didn't know what the field was. They just happened to pick it out of the catalog. So I think this particular degree gives us a great opportunity to at least help with the problem of recruitment and diversity. I think we have I guess I just would close and say, like, I feel like it's easier to do it there than my other computer science classes. Both we need to solve the problem in a lot of places, but I feel like I have a greater ability to solve the problem in the data science field. And maybe that's because, I can really try to motivate with this matters in healthcare, it matters in finance, it matters in whatever you're interested in, whether or not you want to do climate change, whatever it is, like, we can talk about your problem that you're passionate about, and that'll attract a diverse group of people, I think.
So I'm going to second Paul's sort of observations in that I sort of seen the same thing in our program in terms of our enrollment. It's fascinating when I've gone to some of the data science conferences. So I've attended Do Good Data twice now, and both times I'm always amazed by the fact that I'm pretty sure that like 60 to 75% of the attendees are women, often with a much higher minority content than we often see at other things. That said, when I go to some of the more traditionally computer sciencey conferences that might have some strong data science, but are still mostly computer science conferences, you see a lot less women and a lot less minorities. Although they can be better than the general, the pure computer science fields. I see that in like my graph theory stuff that I go to. There's a lot of women and a lot of minorities engaged in that, which is sort of a field of data science. So I think that Paul hit it on the nail with saying this is data science is sort of a way to get women's and minorities' foot in the door in these technical fields and perhaps make a change back into computer science.
Yeah, that's also my observation here at Auburn with our undergraduate programs. We see about the same number of female, and there is a balance between number of female students and male students. But for our graduate program, there are definitely less females out there. And about the pre-required courses, I think I agree with you guys. I don't think there should be any pre-required skills. I think one of very important characteristic is as long as you are curious, the curiosity is a very important feature. You have to have that desire to look into the data set and dig into the data set.
Yeah. So, I mean, this is something that's interesting. The question of prereqs comes up a lot. And so I wanted to get at also, each one of you talked about, and this came up, is a communications being key. And in some of the other work we've done, we had math, stats, computer science, coding. Communication has come up with a lot of our industry partners, as well as the idea of ethics, of how do you take the data and use it in an ethical manner. So I'd like you to comment, are there, I heard communications and what that really entails for you, what it means, whether it's visualization or communicating ideas and presentations, and if there's any component of ethics or responsible data use in any of the curriculums here. So I think the communications question actually was initially focused at pay. So I'm going to have you start.
Okay. Yes, we actually have a course offered around this one. It's about communicating the quantitative results. We start with understanding, making sense of business program. That's communication between the company, the parties that having the question between the students, and then later the last step is delivery results. Yeah, that's what we mean by communication here. And one important feature actually not related to business analytics is how you present through PowerPoint slides, right? How you copy those graphs that you get. And here at Auburn, how we training students, we have students when they finish their analysis, we have students writing an essay report, follow a certain template. It's like writing a journal article or we start with highlight the business implication and introduction and describe your business program, and also describe your data, describe the model you used. And also what kind of business implications you are drawing here. We kind of follow different steps, having students follow the template and deliver their results. And about specific tools we use to visualize, and we are using SAS Enterprise Visual Analytics. And also, while we introduce Python and R, they also have very useful visual packages. Some of the things we are doing here.
So since there's also a question about assessment, I'm going to hit two birds with one stone. Casa, can you share I shared my screen. I don't know if I'm coming up now with are people seeing my assessment plan?
Yeah, it's up. You're good
Fantastic. To go. So we don't have any course explicitly on ethics, but of the 4 things that are in our assessment plan, one of them is ethics. And so that's sort of this 4th one here. The students will be engaged and aware of with the use and misuse of statistical data. And we tackle that by explicitly talk about having ethics case studies in our capstone sequence. So for 3 years, they're discussing ethics as part of as they're growing about maturity and things like this about data. And this gives them a chance to sort of really engage with it early in their career, but then also as they move through their curriculum, they sort of grow in their understanding of how data can be used. They can also grow in their understanding of how data can be misused. And I also usually like to include that in like my intro classes and other things. And then you can see here that sort of the rest of our programmatic assessment is related largely around sort of The capstone courses, so the capstone course, they're doing a presentation where we're looking to assess some of these communication skills, and then some of their ability to do things, so like work with problems and code things and tackle problems are assessed through some of our project heavy classes and some of the other standard classes. And I'm done now, so someone else wants to talk.
Renata, you're muted, so we're not quite hearing you.
Yes, that would be good. So you have the ethics, Carl, built into your capstone projects and how they're designed. You have some that talk about that. And interesting. So that's very interesting. Was there anyone else that wanted to respond to this question?
So typically we include ethics at the undergrad level kind of buried in all of the classes because we do a lot of like experiential learning with healthcare data or different data sets. So there's lots of regulations around that. And then some of the people that are involved in some of the labs, there's the CITI kind of ethics training that's required. So it's embedded in almost all of the classes instead of having its own standalone class. Mm-hmm. But for the PhD program, we're definitely having to kind of reevaluate that model because they're going to be the ones leading the team and really strategically thinking. Mm-hmm. So they'll need some sort of more embedded ethics course that maybe even gets in some of the legal requirements and more of a big picture concept.
That's interesting. So at the PhD level. I mean, that makes sense in the sense that they'll be project leaders. So I wanted to open, also, go ahead, Mary. I saw you unmute.
No, just real quick. We address it right at the beginning. We use the cross-industry standard process for data mining in all of our data science classes. Mm-hmm. And it's if you look it up, it's got an acronym, CRISP-DM. And that addresses a lot of the ethical issues as well as just best practices for how to manage a data set and how to do data mining in an effective and in a way that does not cause you to put your own ideas into that data set. So if you've never done data mining before, you don't know what I'm talking about, but there are ways of cleaning data sets where you could end up throwing out data or including it for the wrong reasons. And so we want to be able to make sure that students are making decisions about data that abide by these best practices.
Yeah, this is very, very true. You know, so before this, in my iteration of working with the government, with the NSF and with the White House office, we did talk a lot about this idea of data being such the new gold in companies and how that's being used, but also in the social and political sectors as well as academic sectors, and the amount of people that are actually equipped to know, you know, when are you putting your own, you know, bias in some ways into the data analysis, and how is that translated when it's an algorithm or a rolled up process or a machine learning thing. There's no auditable trail. So, you know, that's something that has come up in other settings. And I want to leave it open. We've had a lot of good questions, and from the group that's online, I don't know if we heard it before I cut off before, but there is a community, there's a website for this series, Keeping Data Science Broad, which is on the South Big Data Hub main page. And it also, so we'll have webinar 2, but there's also a community input form. So if others have programs or input on these topics, you can go there and fill out the form in whole or in part as many times as you would like. As new things come up after you view these webinars, if you change your mind, you can go back in. We will definitely wrap those up into a report that we want to, you can opt into getting the report at the end. As well as part of it, one section shows you through the hubs. I'm collecting data science programs. We have about 500 right now across the country, and looking at just where they are and visualizing that for the South and for the US and what departments they're in. So I think it's a little tiny link on maybe, you know, page 3 of the community input form, but it will make it bigger on the website as well, where you can see what that visualization looks like of the different data science programs across the country. And if you're interested and being a case study, for one going forward. So with that, we're exactly 1 minute off time. I'd like to thank each and every speaker for not only your great speech today, but also for your fantastic programs. And hopefully that we'll see you again in the future and you can be connected with the Hub. As a brief background, this is part of the Human Data Science Broad, but the South Big Data Hub, as well as the other 4, are really about making this bridge around data science between industry, academia, and government in order to serve society at large. So we have projects that are, specifically cross-sector that solve a grand challenge for the nation. And we're interested in education as one of those grand challenges. And that's where we would love to have people join and also get involved in this effort specifically. All right, well, with that, thank you. And thank you, Costa, for holding us all together, even when my internet went out.
No worries.
Thanks for having us.
Thank you.